After our first video about building an MCP server for Apache Druid and using it, we got a lot of feedback. And one of the key points was, how do I run that on my data source without sharing all the information with a big provider? Because that's the key point in an enterprise, to keep your data private and not to share it just over the borders of your enterprise. So we asked ourselves one question. How can we create a complete local running AI agent that runs on a normal computer? Not that you need a big GPU cluster or so. And the second question is, when it runs locally, does it suck or is it comparable to OpenAI? So here we go with our newest development called Data Philter. In short, a complete package setup for a local AI installation on a computer to then utilize the Druid MCP server without compromising anything of data privacy, that no data is going outside. It all runs on your computer. And we compare how does it run on OpenAI and how does it run on a local computer. And we tested it for Windows, for Linux, for Mac. We now go to check the capabilities, and then we talk about what can we downsize, and then we see a little bit of the compromises, but ultimately, a little bit spoiler ahead, it runs all on a machine, and we think it's worth the compromise. Let's go.
Let's go. I also want to say hello to everybody, and I also want to reference you to the other video where we have combined the Apache Druid MCP server with Apache Druid and made all the data science stuff and so on, between local LLMs and an OpenAI-based backend. We have the automatic installation with a macOS Linux one scripter and Windows. There's also manual installation if you want to go ahead and deep dive into that. We just copy that single command line in the terminal, just paste it in. Then we can choose which provider we want to use.
So we just start here with OpenAI. So basically, when you want to use it completely locally, you choose here an Llama model. As a reference, we start now with OpenAI. Then at the later point, we execute the same thing again, and we then do it in different model sizes on the computer.
For the video, obviously, I will not put any secrets in. I will stop the video and then do it again. The first thing is you enter your OpenAI API key. The second thing is you enter your username. And the second is you enter your password. Then you enter the Apache Druid URL. And then the app is going to start. Voila. So now we can start already with the first use case.
Okay, yeah, we have here different examples, and the key thing, what happens is you take this complete tooling and then send it to the LLM, and ultimately then the local machine execute the tool calls. Succeeding, the result of the tool calls gets processed by the LLM and formatted and presented to the user. What we will do is go for list my data sources, that I see the data sources of Apache Druid. Then we are executing a few queries. Does it work? Does it find the tools? Can we operate our time series database from here? So that's what Chris is going to do now.
Okay, let's start with list my data sources, as you just mentioned.
So it finds the right tool from the written language. It was just written language, and then the tool determination is automatically. Then we see our different data sources, and now one could say, show me details of segments of the Potsdam data source, for example.
Yeah, we start a new session. We say we write a query from the first data source in your Apache Druid. For that, list the data sources first, and then use the query SQL to do select count from.
This scenario is quite difficult because it's a chained tool execution. And so it needs first to call the first tool, then to get the results out of the first tool and use it as an input for the second tool. And that is not so easy for an LLM, not depending on the size and the capabilities. So here it worked well. This is why we use that as a test case, because in special smaller ones, sometimes running endless loops and so on. And that is why we use this here as test case. So that worked wonderful. We have now the count, and now let's see if it can relate to the history.
Okay, what he did do here is to select counts from the far few seconds, and we want to tell him, do the same for the Potsdam V8 data source.
And when you want to know something about the data sources and so on, and in the last video, we really did a very big examination of all of that.
The last video is definitely a recommendation. So this worked. He was running again the list data sources. This time he was running the query Druid SQL query against the Potsdam V8 data source. So, and this is the count from that. And we have a couple of more in the far by few seconds, just to tell you in advance. Yeah. In the next case, we want to tell him, hey, I want to have a complete overview how many rows each data source has. So we tell him just run select count queries for each data source. Let's see what he is doing with that.
The important thing is here, does he loop over it? Does he forget data sources? Does it work completely? And because that on the capabilities of the model is always different now, or does he call duplicates and so on? You saw already in the first thing that this is, I think it's an O5 mini, Chris?
Yeah, what we use here is a GPT-5 mini.
The bigger the model, the more expensive the model, the more intelligent it is. But we think that the key thing is what we have here is in Struct case, we want to use a model to investigate our local data sources. So it's not so bad when it calls multiple times or so. But this here is the reference from OpenAI online on their servers. And
we want to present it in a markdown table, and this is our final test step for this. What we could do is we could tell him, hey, run a direct Druid SQL query. Let's try that. Fire the following query. And this is what happened. Yeah, that's fine. I want to mention one thing. In the current scenario, we run the Druid MCP server in the read-only modus. This means that we are only able to use list, show, and query, so read actions on the Druid itself. If we want to create an injection, create a task, we would need to change this setting to false, and then we could do much more, and we could use much more tools as well.
The reason why Chris says that so explicitly is because we got some feedback after our last video and after people downloaded our MCP server that they want a read-only mode where they are safe that they do not write anything on Druid and just wanted to have it for analysis. So when you use that safe for children, you cannot destroy anything.
So this was OpenAI. We are going to switch now to Ollama model.
Yes, so Chris is now just running the installer again. You can then decide to override here. You do not need to edit any environment variables or so.
We want to keep the Druid environment because Druid environment works, and we will recreate the app environment. And this time we're going to use Ollama. We start with the XL model.
We have now the thing. Now we take a really big Llama model. We take the GPT 20B, right?
We use the GPT OSS 20B, yes.
Yes, so it's quite large because if that runs on his computer, we can say it runs also on a very good server without a problem, and it's solvable.
Exactly. So we have 3 Ollama-based models. We have the Ollama M model, which points to the Aura M model, and this is based on Granite 7B. We have the Ollama L, which is a fee-based model with 14B modifications of us, and the Ollama XL model, this is the GPT OSS 20B model.
Maybe a few words about these models. The thing is, we checked in each model class, in each size class, what works the best with tool calling. The Granite from IBM, we saw that is the best in this class at the moment, adjusted it a little bit. Then we used P model from Microsoft that worked then best in that class. And then we saw in the larger class GPT model working best. We will tune this model further. We also have in plan to make an S model. But first of all, we want to get a little bit of feedback, what kind of machines you use and so on. So we have different tiers more or less.
I have currently an M2 Max with 64 gigabytes of unified memory. So I'm able to run all of these 3 models, no issues. And I think less memory would still work. Would be glad if you get some feedback from you and your hardware sizes and so on. Give us your feedback in the comments. For the YouTube algorithm, the comments are the best. You can create GitHub issues as well via email if you want to keep it private. We started the installation again. We're going to use now 20B model. This is the XL. The script is now trying to start the Ollama server in the background. If Ollama is not installed on your machine, the script will try to install Ollama with a normal installer. You can do it by yourself, no problem. If we have documented the uninstallation routine as well, so everything is safe. This is Docker-based. The minimum requirements of that is Docker installed. That's it. If you don't have a Apache Druid server available, or you don't want to test with your production one, we also created a very similar script, which is called Druid Local Cluster Installer. I will link that also in the caption. Data Philter is trying to pull the model if the model is not available on your machine. So obviously with the 20B model, this might take a while. We do the same exact test case again. We try to list the data sources. You see, it uses the list data sources tool, and these are the list of the data sources rendered in Markdown. Beautiful. Okay, now the second use case, we make the double tool call. Now we list all data sources on the first data source it finds. It will run the SQL query for above used second. Okay, and there we have the result. And as before, we do the same with Potsdam V8 now. That's fine. And then we want to do that for all of the data sources. You can also check which tool calls happened here. Last thing should be Potsdam. And this is already rendered Markdowns. Our last test was fire this one. Let's see how good this works. Fine. He understands that with fire this one, he has to call the Druid SQL query tool, so he's smart enough to do that. And this was our very stupid group by query. Okay.
Short conclusion, this is on par with what we have seen online. Now let's take the next smaller model.
We run the script again. We overwrite the app env. We keep the Druid env because this stays the same. We say we want to have Ollama, and we want to use the large model this time. So Ollama is starting in the background. We wait for the app to come up. Okay, we say again, list my Apache Druid data sources. Oh, that works fine. And the second thing is the same test cases again. Right from the first data source you find in the Apache Druid, write the select count query. So the double tool call. Okay, that's fine. We do the same for Potsdam V8.
Again, it needs to understand what is the same, what is from the past. So that gets more and more difficult the smaller the model gets. The model is still able to handle it, to understand what is the same when it executes it.
So the first thing is he will try to list all data sources again. And then he's running select count on each.
So it seems he's executing the plan. It's also interesting to see that each model is handling the tasks differently. The key thing, what makes it so difficult, is that it needs to understand when it stops. So to plan it first, then to execute the plan, and then to stop and halt at the end. In our tests of different models, of different vendors, of different sizes, that was the key challenge. So with the configuration of the system prompt and so on, that it really halts at the end. That is why we were using different models for different sizes. But we see here that this here is a lot more struggling with the task than the model before.
I want to have that in the Markdown table. Okay, that's the result in the Markdown table.
This model struggled a little bit more. I still think it's executable in special when we look at it, what we want to do. We want to query data. We want to ease our life. I see it as an alternative in special that I don't need to pay credits and so on, and that it runs locally, and one can, for exactly that kind of task, to investigate data.
Same again. Create that with the M, say Ollama, medium, go. We are now on the Aura M model, which is based on a Granite 7B model. Let's go with the first test case, which is just list my Apache Druid data sources. And you will see that will also work quite well. That's good. We go with the right Druid SQL query from the first data source he finds in the list data sources. So the double tool call. Again, this worked quite good. And then we want to run the select count query for each data source he found. Okay, now we see we have only 2 data sources found.
That is the exact difference when you look at these models. That is a little bit number, so to speak, and it sometimes is a bit sloppy. But when you see the speed of it and the computers where it runs it, so it runs without a problem. We need a certain amount of memory, but not so much.
Okay, this is how we overcome that. We give it a little bit more context compared to what we have done till now. We say, okay, we want to have all of those, and we want to tell them that was not an idea. Run a select count for each data source here. and present that in a markdown table.
So Chris is lifting it to the level that it does not need to look in the context. It can look at the current message and it doesn't need to look at the history. And that is not enough. We need a little bit more help.
Okay, retry. So we have results for those tables.
Let's see if it's recovering it. You see, it's still pretty intelligent when you compare that. It's not perfect. We use a lot of time that it does not hallucinate. The key thing is usable.
To show you again, we are here on a model which is very small. You could see he's capable of doing the tasks, but sometimes he might get issues. I have seen very similar also with bigger models like in Claude. He's losing information, that he's doing stupid things. And queries on our prompts here have on purpose be very stupid. We have just gave him a little hint and say, go ahead.
Just trying to explain that we did not give that a lot of context. So what you can do is the more you describe it and the more discrete you are in your instructions, the more easy it will be in tool following. Let's give it one shot, and that is start a complete new chat session. So when we take this instruction and now we reformulate it, let's write it different. Let's say, here is a multi-step plan.
Now we have the select count for all of those data sources rendered in a beautiful markdown table. Okay, that's it.
So this is not on the level of O5 Mini. The other ones, I would say, are a real alternative. In future, we will come back with fine-tuning this and even introduce a smaller model that runs on even smaller machines. In order to do that, we need your feedback for that. It's quite important. And also you can reach out because only feedback helps to advance all of that and to see the use cases where we training these models better, and then they understand better. And for that, we need feedback to know exactly what comes out. So we see it's an alternative to run large language models on your computer. Data security all ensured.
I want to encourage you, try it yourself and give us feedback. Installation is very easy. The only prerequisite we have is that Docker is installed and you have a Apache Druid cluster available in the current thing. We will extend this data filter also with Postgres and ClickHouse in the future. Let's see how it works. Depends a little bit how much adoption we have on that. Anyways, I would thank you for watching this video till the end. Leave us comments, leave us stars on the GitHub project. We really, really appreciate to hear back from you guys. Till next time.